In this next video, we're going to learn how to use the mole formula as well as its arrangements to calculate the number of moles or even the mass of particles. This can be molecules and ions that are in a sample. So this is our science understanding. So to calculate the number of moles of particles in a sample, we can use this formula here. So N equals M over big M. And we can rearrange this to work out mass as well. And we're going to do this for a range of molecules and ions and their compounds as well. So just to remind you, this is the mole formula that we've seen previously, and we've used this to calculate the number of mole as well as the mass of various atoms in elements. So we're just going to extend that further to talk about molecules and also ions present in compounds. And just keep in mind that we can simply rearrange this formula. So this formula N equals little m of big M, and we can rearrange it to get a formula for mass. So that's mass is equal to the number of moles times the molar mass. To look at how we use this, we're going to work through a few examples. The first example looks at sodium hydrogen carbonate. This is also known as baking soda, and it's primarily used in baking as a raising agent. The question states, calculate the number of moles of sodium hydrogen carbonate in a 45.20 gram sample. So to calculate the number of moles of sodium hydrogen carbonate in this sample, we're going to need to firstly work out its molar mass. So that's the mass of 1 mole of sodium hydrogen carbonate. Let's do that first. So the molar mass is equal to, and we've already learnt how we can do this. So we've got the mass of sodium, 22.99, plus the mass of hydrogen. So these numbers you can get from your periodic table. 1 carbon, and finally 3 oxygens. And if we work this out, we end up getting 84.008 grams per mole. We're going to now use this molar mass in the formula, and that formula is N for sodium hydrogen carbonate is equal to little m over big M. So that's going to equal our mass, which is given as 45.20 to 4 sig figs, divided by 84.008, and we end up with 0.5380 mole. We're recording that to 4 significant figures because keep in mind that our original data, this mass here is recorded to 4 sig figs. Our second example is looking at aspartame, C14H18N2O5, and this is used often as an artificial sweetener. So we see it in diet foods like Diet Cokes, coffee, and soft drinks. We want to calculate the mass, in this case, of aspartame if there are 0.765 mole of it present. So we're going to need to use a rearrangement of this mole formula. So again, we need to calculate the molar mass of this aspartame. So the molar mass is going to equal the mass of 14 carbons. That's 12.01, 18 hydrogens, 2 nitrogens, and 5 oxygens. Plug that into our calculator, we should end up with 294.304 grams per mole. And we need to use our rearrangement of the mole formula, so that's the mass of aspartame. This is equal to the number of moles multiplied by the molar mass. So we've got 0.765 to 3 sig figs multiplied by 294.304. And if we work that out, we end up getting 225 grams, our mass, to 3 sig figs. And if we have a look, our number of mole is given as 3 sig figs. So our mass should be given to 3 sig figs as well. For our third and final example, we're going to look at magnesium hydroxide. This is an ingredient we often find in antacids. So that helps relieve acid indigestion or acid reflux. A particular brand of antacid tablet contains 0.299 grams of magnesium hydroxide. So the first part of our question, we want to calculate the number of moles of magnesium hydroxide. So we learned how to do this in the first example. First thing we'll do is just work out the molar mass. So we've got 1 magnesium, If we have a look at the formula, this hydroxide is in brackets. We've got 2 of it, so that gives us 2 oxygens and 2 hydrogens. So we're going to add that to 2 oxygens and then 2 hydrogens. And that'll give us molar mass of 58.326 grams per mole. We then need to work out the number of moles. And so that's using our formula little m over big M. We've got our mass of 0.299 in the tablet, divided by the molar mass, and we get an answer of 5.13 times 10 to the negative 3 moles, and that's recorded to 3 significant figures. And again, we can see our mass of the tablet is 0.299 grams, at least what contains the magnesium hydroxide. Another type of question that we could get, once we've actually worked up the number of moles of magnesium hydroxide, we might then be asked to calculate the number of moles of magnesium ions. So if we have a look at the information from part A, we already know the number of moles of magnesium hydroxide is this here. And if we were to treat this as one unit, so we call it a formula unit, for every 1 formula unit of magnesium hydroxide, we would have 1 magnesium ion. We would also have 2 hydroxide ions. So we can then apply that by talking about moles, and if we had 1 mole of magnesium hydroxide, we would have 1 mole of magnesium ions, and then 2 moles of hydroxide ions. We don't have 1 mole, we have this specific number of moles, but what we know is that this is going to be identical, so the number of moles of magnesium ions is going to be equivalent to the number of moles of magnesium hydroxide, so we can then simply state that as 5.13 times 10 to the negative 3. Lastly, if we have a look at the calculation for the number of moles of hydroxide ions, I've already mentioned this. So again, if we had 1 mole of magnesium hydroxide, we would have twice that number of hydroxide ions. That's because we've got 2 lots of hydroxide per unit. So again, using our previous information, knowing the number of moles of magnesium hydroxide, the number of moles of hydroxide is going to be twice the number of moles of the magnesium hydroxide. So we just multiply by 2 and we end up with 1.03 times 10 to the negative 2 moles. So hopefully after watching this video, you'll feel quite comfortable being able to use this mole formula to calculate the number of moles or even the mass of molecules or even ions that are found in various compounds. See you guys in the next video.